Shake Table Lab by Will Cummins and Isaac Kim. My partner, Isaac, and I decided that we would make each floor the length of one straw, which was 18 centimeters. The tower had to be at least 36 centimeters. We planned to have our tower become smaller towards the top. Our base would have a length and width of 18 centimeters, and the top of the second floor would have a length and width of 13 centimeters. I have almost finished the base of our tower and the support beams. Isaac is going to work on getting the base of the first floor. He's going to put straws on top of the support beams to make the outline of our floors. The cross beams are in for our first floor, and we have worked on the actual floor in the middle of the tower for the second story. Our cross beams are getting worked on for the second floor, as the outline is for our roof. We have almost completely finished our shake table tower. All of our cross beams in the flooring structures are in, but we still need to add the roof and the paper floors. Isaac and I have completely finished our tower. For our roof, we decided to do a wedge, but it was a little bit more unique than expected when we finished. After we finished, our tower ended up having a total height of 71 centimeters. Each story was 21.5 centimeters high, and we didn't exactly copy the cross beams. There are two 250-gram weights on each of our floors, and our tower seems to be holding them up just fine. Our static testing was successful, and no straws were bent or broken. To strengthen our tower, we added in cross beams. They helped strengthen our tower because they stabilized and straightened out the tower, so it didn't lean or tilt. By adding cross beams, our floors were provided with support, and the cross beams carried some of the weight. The strongest part of our tower was the double uprights, or corners that we put to strengthen our tower. Isaac and I's tower had a less chance of breaking with these because the straws are twice as strong and will be harder to bend and snap in half. Our floors were the weakest part of our tower because they had the least support. We didn't add in center supports, and we only had cross beams. If we did add center supports, they would hold up more weight and our floors would have a less chance of breaking. Tape was used in many places on Isaac and I's tower. One place we used tape was on the corners, where we connected straws. Every place that straws intersected is where we used tape. Also, we used tape when connecting the crossbeams at the center. Some extra supplies we used for our tower were pieces of paper as our floors, so the weights could sit on a flat surface. Everybody received 5 extra straws too, because Mr. C felt like we didn't have enough. For our roofs, we could use as much straws as we needed, because those straws on the roof didn't help support the tower. They were just for decoration. There are currently 14 sandbags on our tower, and this is the point where it started to shake with great force. It is wobbling and the crossbeam supports are bending.
Alright, good.
It's your blood watching. Oh God, oh no, it's shaking. It's jiggling. It's flexing.
With 18 sandbags on the tower, it collapsed. The straws began to break and pop out. If only it survived for 2 more seconds, we would have gotten 18 sandbags rather than 16.
It's gonna fall, this one. There's no way it's gonna live.
Shock absorber.
There's no way.
Oh wow.
There's no way.
Oh wow.
Fall.
Don't fall. Oh my God.
Yes!
Oh, my tower. Oh my God.
According to the sensor readings, our tower shook the most on the x-axis because the lines are the longest. The x-axis is side to side, the z-axis is forward and back, and the y-axis is up and down. Our tower shook the least on the z-axis, which is up and down, because the lines are the shortest and the closest together. I'm Will Cummins, and our tower supported 16 250-gram sandbags, and after 12 sandbags, it was pretty obvious that the tower was going to go down soon because the straws were beginning to flex. And our building failed because the first floor, the cross beams, were beginning to bend and there wasn't enough support to hold up all of the weight. Isaac and I could have put some center supports in the middle of the tower so it could support some of the weight also and not have all the cross beams do all the work. And I learned that if you want to build an earthquake-proof tower, you have to have like the skeleton of the building inside, so it's not just cement and there's something to hold up the building. And I enjoyed this project because I like to see how the tower got stronger when we strengthened it and added more straws. I like to see how it got stronger as we went, and I liked working together with my partner Isaac. Thank you.
My name is Isaac Kim, and my Shake Table Lab partner was Will Cummins. Our building supported 16 sandbags, and when it was 14 sandbags, our buildings flexed a lot and the straws began to bend. The place where our building failed was the first floor, and the reason was because we didn't add the center beams and we added too much straws at the bottom. And if we could change one thing, then I would have added the cross beams so that it could support more weight. And if what I learned about the earthquake-proof building is that we need a skeleton inside the building so that it could support the building more and better. And lastly, I enjoyed the Shake Table Lab project because I like cooperating with my partner and I like to see our building fall. Thank you.